Welcome to Ordinary Fancies. I'm Linda and I'm a fancy goldfish hobbyist based out of the United States. I use this channel to share what I've learned in hopes that it'll help you succeed in taking care of your own fancy goldfish. Today's video is all about understanding alkalinity. If you don't know what that is or why it's important, then keep watching because a low alkalinity can lead to the sudden death of your fish and it's totally preventable. So let's dive in. First things first, what do I mean by alkalinity? I'm talking about your water's ability to neutralize acids. You may not realize this, but acid is being produced in your aquarium all the time, 24/7. Just like us, the fish and bacteria in your aquarium are producing carbon dioxide 24 hours a day simply by breathing. As the carbon dioxide dissolves in the water, carbonic acid is formed and hydrogen ions are released. A high concentration of hydrogen ions in water is what makes water acidic. Algae and plants also release CO2 at night or when it's dark, and those with planted tanks who are injecting CO2 into the water are obviously also increasing the carbon dioxide load in their aquarium. So CO2 injectors, algae, and plants all contribute to a more acidic environment. The other main contributor is the nitrification process. I'm talking about the process in which the beneficial bacteria in your tank consume the toxic ammonia that's coming from your fish's poop, uneaten food, or dead or decaying plants, and converts it to less toxic nitrite and then nitrate. Hydrogen ions are released during the nitrification process, making water more acidic throughout the day. There's one more potential source that I know of, and that's stuff that can release tannins into the water. This would be things like driftwood, peat moss, or catappa leaves. When tannins dissolve in water, they release hydrogen ions. So objects that release tannins also have the potential to increase the acidity of your water. And what happens when water becomes more acidic? The pH of the water starts to drop. And if there's nothing there to neutralize the constant accumulation of acids, then the pH in your aquarium could eventually drop to a point where it can no longer sustain life. This can literally happen overnight. The pH of your water needs to stay above 6 and ideally above 6.5 in order for most fish and most beneficial bacteria to survive. So if your pH falls below 6, you could potentially wake up one morning to an aquarium full of dead fish. This is the phenomenon that people are talking about when they mention a pHcrash. It means that too much acid accumulated in the water failed to get neutralized and caused the pH of the water to fall below 6, killing all the fish and beneficial bacteria along with it. Even if the pH of your water doesn't fall to a deadly level, sudden large swings in pH also are detrimental to your fish. The pH scale is what scientists call logarithmic. This means that if your pH changes by 1 unit, your water has become 10 times more acidic or 10 times more alkaline or basic. And yes, I did say 10 times. For example, if in one day your water goes from a pH of 7.8 to a pH of 6.8, that means that your water became 10 times more acidic that day. As you can imagine, this is not great for your fish. A significant change in acidity is going to cause your fish's body to go into overdrive, trying to prevent its blood pH from falling. And when the body is focused on this acid-base regulation process, it doesn't have enough energy for normally bodily functions. For example, things like swimming, digestion, growth, or fending off disease. So as fish keepers, it is our duty to make sure that these big swings in pH don't happen. Fortunately, we do have some help from Mother Nature. Alkalinity is nature's way of keeping pH stable even as acid continues to accumulate in the water. This is done through the existence of acid neutralizing bases, such as bicarbonate ions and carbonate ions. These ions are like sponges for hydrogen ions. They absorb the free-floating hydrogen ions in the water and neutralize them, preventing them from increasing the water's acidity. Unfortunately, bicarbonate and carbonate ions are exhaustible resources. Once they bind with hydrogen ions, they are no longer available to help neutralize acids. And once all of the bicarbonate and carbonate ions in your aquarium are depleted, your water completely loses its ability to neutralize acids. That's the moment when even a very small increase in acid production could cause the pH of your water to fall to a deadly level. So it's important to know how many of these acid neutralizing ions are in your water so that you know when you need to step in and replenish the supply. And the way to do this is to test the KH of your source water. KH stands for carbonate hardness. It's a measure of the number of bicarbonate and carbonate ions in the water. It's usually measured in parts per million, ppm, or in degrees of carbonate hardness, DKH. 1 degree of carbonate hardness is equivalent to 17.9 parts per million. Not all water has the same KH. So if your source water, for example, has traveled through areas with lots of limestone or carbonate rocks, it likely will have a higher alkalinity. But if your water comes mostly from rainwater or melted glaciers, for example, then it'll likely have a lower alkalinity. If your water source has a high alkalinity, it's very likely that it will be able to maintain a stable pH on its own, as long as you're keeping up with your water changes. But not everyone in the aquarium hobby is lucky enough to have a source water that's high in alkalinity, myself included. So if you have a source water that is naturally low in alkalinity, it is very possible that the bicarbonate and carbonate ions could become depleted in your aquarium before your next water change. And if your KH is very low, it's possible that you don't even have enough of those ions to keep your pH stable for even a day. How do you know which bucket you fall into? You have to test your water and experiment with your particular aquarium. As far as testing goes, there are different ways to test your KH. But I think most hobbyists use this liquid-based KH test kit made by API. All you have to do is fill a test tube with some water from your tap and add a drop of this solvent in there one at a time until the water turns yellow. You add a drop, you close off the test tube, you give it a little shake, and then check if the water has turned yellow. If it turns yellow after the first drop, it means you have very low alkalinity. If it turns blue, then you need to repeat the process. You open up the test tube, add another drop, close it up, give it another shake, and check again to see if it's still blue or has turned yellow. You keep doing this over and over again until the water turns yellow, making sure to keep count of how many drops it took to turn the water yellow. For example, if it took 6 drops for the water to turn yellow, it means that your water is measuring at 6 degrees in carbonate hardness, or 107 parts per million. Water with high alkalinity is known to measure at or above 10 DKH, or above 179 parts per million. Water with low alkalinity is known to measure at or below 3 DKH or below 54 parts per million. The pH of my tap water is only 2 DKH or 34 parts per million, so it's pretty low in alkalinity. If your water is above 10 DKH, it's very likely that you won't have to worry at all, as long as you're keeping up with your water changes. If your water measures at 3 DKH or less, then you definitely will have to intervene. You will have to replenish those bicarbonate and carbonate ions. If your water measures somewhere in the middle, like between 4 and 9 DKH, then you're going to have to do some additional testing to see how much your KH is dropping between water changes. Your particular aquarium and maintenance habits are going to impact how much the KH drops between water changes. For example, if your DKH is at 4 and your tank is overstocked and you're performing 30% water changes only once every 2 weeks, it's very likely that your bicarbonate and carbonate ions are going to become depleted. But if, as another example, your DKH is at 4 and your tank is understocked and you're performing 30% water changes twice in 1 week, then you're probably going to be okay. There really is no hard, fast rule. You have to test the KH and the pH of your source water and of your tank water in order to figure out the alkalinity situation in your particular aquatic environment. So I suggest starting by testing the KH and the pH of your source water. For most of us, this is going to be the water that comes out of our tap. You're going to have to conduct 2 tests 24 hours apart. I suggest you run the first test 1 day before your scheduled water change. You're going to test the water that comes straight out of your tap, and then you're going to let it sit for 24 hours, ideally with an air stone in it. And then you're going to run a second test 24 hours after it's been sitting out. This gives enough time for any gases to release and dissipate that would have otherwise provided a false pH reading. The thing is, tap water can be temporarily undersaturated or oversaturated with carbon dioxide when it comes straight out of the faucet. So when that happens, you could be getting an artificially low or artificially high pH reading. Allowing the water to sit out for 24 hours gives it a chance for the CO2 levels to stabilize. And this will give you a more accurate reading when it comes to your source water's natural pH. For example, my water straight out of the tap reads at 7.8 pH. And if I let it sit out for 24 hours, then it actually lowers down to 7.4. So 7.4 is the true natural pH of my tap water. Next, you're going to want to test the KH and pH of your aquarium water. So right before you do your water change, that's when you want to test your KH and pH. Next, I suggest doing an additional test of your KH and pH about 2 hours after you have filled your tank and allowed the filter to run. That way you can see how the water change has impacted the KH and pH of your water. And then what I suggest is that you do daily tests of your KH and pH throughout the week or however long it takes between your water changes. And then make sure that you write all those numbers down because you're going to look at them after. The other suggestion I have is to test your water at the same time each day or around the same time each day. This is because the pH of your water could naturally fluctuate throughout the day. If you have a lot of plants or if you have a lot of algae, what's going to happen is that during photosynthesis, the plants or algae are going to remove CO2 from the water, thereby making it more alkaline. And then at night, they're going to release CO2 in the water and they're going to make it more acidic. So by testing the water at the same time each day, you're going to be able to get a more accurate picture of what's really happening with the pH and KH in your aquarium. Here's an example of the data I collected during my last set of tests. Straight out of the tap, my source water measured at 2 DKH and 7.8 pH. After sitting out for 24 hours with an air stone, the DKH remained at 2 and the pH stabilized to 7.4. Before my water change, my aquarium water measured at 4 DKH and 7.8 pH. With the addition of a commercial buffer, 2 hours after my water change, my aquarium water measured at 5 DKH and 7.9 pH. My daily water tests indicated that within 5 days, my KH started to decrease and went from 5 DKH to 3 DKH, and the pH decreased also from 7.8 to 7.6. After adding a little bit more commercial buffer on day 5, my KH and pH were able to stay stable until my next water change. So based on my results, my particular aquarium ecosystem, with the help of a commercial buffering agent, more on that later, has sufficient alkalinity to neutralize acids and maintain a stable pH of 7.8. If between water changes you find that your KH stays above 3 DKH and that your pH doesn't fall by more than 0.2 units, then you are okay. You don't need to do anything because your particular aquatic ecosystem has maintained a sufficient balance. But if you find that your pH is falling to 3 DKH or less, and or your pH is going down by more than 0.2 units, between water changes, then you really should be stepping in and helping to replenish those bicarbonate and carbonate ions. There are many ways of accomplishing this. One way is to increase the frequency of your water changes. As long as the KH of your source water is not too low, then this will be able to increase the supply of those acid neutralizing ions in your aquarium. Just be careful if the pH of your source water is very different from the pH of your aquarium water. You don't want to cause a large swing in pH just by doing the water change. So if this is the situation for you, then I suggest that you do smaller water changes, or you go ahead and let the new water sit out for 24 hours before adding it to your tank. But if adding more water changes to your schedule is not realistic for you, then you could use a commercial buffering agent. This is the path I've chosen because I'm kind of lazy and I don't really want to do more than one water change per week. This is the one I use. It's an alkaline buffer by Seachem. I add 2.5 teaspoons to my 78-gallon tank when I perform water changes. I don't add it all at once. I add 1.25 teaspoons right before I start refilling with fresh water, and then I add another 1.25 teaspoons halfway through the refill process. I have found that this is all I need in order to keep my aquarium at a stable KH of 4 and a stable pH of 7.8 between my 50% weekly water changes. Sometimes I do need to add an additional half teaspoon of a buffering agent sometime during the week. Not all the time, but sometimes it happens, and so that's why I continue to test the water occasionally in case I need to step in and replenish those supplies of those acid neutralizing ions. Other popular buffering agents include baking soda, crushed coral, aragonite, sand, cuttle bones, limestone, Texas holy rock, oyster shells or other seashells, and other commercial buffers, mostly in powder form. Baking soda and other commercial buffers are fast acting. They are going to change the KH of your water right away. The other sources I mentioned, like crushed coral, are known to increase the alkalinity of the water more slowly. Some hobbyists will install reverse osmosis units in their home. These are going to produce water that is almost neutral in pH, and it's also going to be low in KH and GH. So these hobbyists will add extra minerals and commercial buffers to the water in order to stabilize it. I don't recommend you do this unless you're an experienced hobbyist who's really looking to have complete control over the water chemistry of your source water. I personally don't use it because it would just be an additional piece of equipment that I would have to purchase and maintain, and to be honest, I'm pretty lazy. I also choose not to use something like crushed coral because I would have to replace it on a regular basis. When you use crushed coral, it's like using carbon in your filter where you have to replace the bags once a month. So I would rather use the space that I have in my filter to fill it with really good quality media that's going to help house that beneficial bacteria long term. I also choose not to use something like crushed coral because the amount of acid neutralizing ions that are released are inconsistent. In the beginning, it might release more, but as time goes on, it might release a reduced amount. So the impact on pH and KH is really unpredictable. So if you want something more reliable, then I suggest you use something like baking soda or commercial buffers, as that's going to give you a bit more precise control over the impact on your pH and KH. It's important that you keep in mind that whenever you add something to increase the KH of the water, it's also going to increase the pH of your water. And if you add something to decrease the KH, it's also going to decrease the pH. So you need to be careful when adding these kinds of buffers to the water. Only add a little bit Test the water to see the impact it's had, and then go from there. The goal is to find the right amount of replenishment needed for your particular ecosystem. For me, that means adding 2.5 teaspoons of Seachem buffer in during my water changes, and then I test my water every other day and I add an additional half teaspoon as needed. I recommend that you not target a specific pH number. Although fancy goldfish might thrive at a pH of 7.4 and are known to do well at a pH of 7 to 8, they can adapt to a pH that is below or above that range as long as you keep it consistent. The key is to choose a pH and KH target range that's easy to maintain and that's also not detrimental to your fish's health. In other words, I don't recommend that you target a pH of 6.5 or 9.0, but I also don't recommend that you target a pH of 7.4 if your source water is nowhere close to that. You'll just end up driving yourself crazy and create a very unstable environment in the process. In most cases, you'll want to aim to maintain a pH that is as close to the natural pH of your source water. This is going to require the least amount of manipulation on your part and maintain a stable environment for your fish. The exception, of course, is if you have a very low pH to begin with. In that case, you probably do want to invest in one of those reverse osmosis units that I talked about earlier. Another way to tackle the issue is to reduce the number of acid-producing organisms in your tank. For example, if your tank is overstocked, then maybe it's time to sell some fish, give away some fish, or purchase a larger aquarium. Do you have large pieces of driftwood in your tank? Then maybe it's time to get rid of the driftwood and change the decor. Do you have a lot of plants or a CO2 injector? Maybe it's time to choose a more minimalistic approach to your tank. Perhaps reduce your plant collection down to a few very hardy plants, or try adding more aeration. In other words, there are many ways to impact the KH and pH of your aquarium. To summarize, test your water, figure out the natural pH and KH of your source water. Figure out what is happening to your aquarium's pH and KH between water changes. If your pH drops to 3 DKH or less between water changes and your pH readings decrease by more than 0.2 units, take steps to replenish your acid neutralizing ions or decrease the amount of acid being produced in your aquarium. Experiment with the different methods that I've mentioned and figure out what works best for you in your unique aquatic environment. And if you're someone with a water source that is naturally high in KH, I envy you. Consider yourself very, very lucky. Before I go, I want to mention one more consideration. Your aquarium is going to change over time. Your plants are going to grow. Your fish are going to grow. They're going to need more food. They're going to poop more. That's going to create more ammonia, which is going to lead to more beneficial bacteria. You get what I'm saying. Therefore, even if you have found that nice equilibrium for your particular aquarium and maintenance schedule, it doesn't mean that you're going to be able to maintain the same routine forever. So I do suggest that you run tests at least on a quarterly basis to figure out if perhaps you might need to tweak something. I also recommend that you perform these tests again if you add more fish or lose some fish, change your filtration, change your substrate, add or remove plants, change the amount of algae you allow to grow in your tank, add or remove driftwood, rocks, or other substrate that could impact KH, add or decrease aeration, change the frequency of your water changes, change the amount of food or the type of food that you're feeding, if you've added medication to the tank, etc. Anytime that you do something that could impact the pH or KH of your water, you should retest because a change could end up necessitating that you tweak your current routine. I know I threw a lot of information at you, but I really hope that it helped you understand alkalinity, why it's important, and how to figure out if you need to manually intervene in order to help keep a stable pH for your fish. Please share in the comments your experience with alkalinity. What's the KH of your source water? How do you test it? What issues have you encountered? What are your favorite buffering agents? If you have found this video helpful, Please give it a like and subscribe for more fancy goldfish care tips. Until next time, thanks for watching. Bye!